you all healthy and happy? We finished our Onam celebration. So we know that tug of war is an important sport which we play during our Onam celebration. What is the speciality of tug of war? Yes, it is a sport where the strength of two teams are tested against each other. So just like the sports, there is a push and pull force between the chemical compounds. So let's study this today. Now you can see the picture of a famous scientist. Can you recognize him? Yes, Linus Pauling. He is a great scientist in chemistry, biochemistry and in chemical engineering. At the same time, he is a peace activist. He is rated as the 16th most important scientist. He won Nobel Prize in Chemistry in the year 1954. He proposed an electronegativity scale, which is most widely accepted. So you can see the picture of electronegativity scale proposed by Linus Pauling. Now we are going to compare the electronegativity of different atoms in a molecule. And we are going to state if it is covalent in nature or ionic in nature. Let's compare.
You can see Lewis electronegativity scale. With the help of this scale, we are going to calculate the difference in electronegativity of the compound. Let's consider the case of carbon monoxide. What is the electronegativity of oxygen? Yes, it is 3.44. And then what is the electronegativity of carbon? It is 2.55. So the difference in electronegativity will be 0.89. So we can say that the nature of the compound is covalent in nature. So now if we consider the case of sodium chloride, the electronegativity of chlorine is 3.16 and that of sodium is 0.93. So the difference is 2.23. We can say that the compound is ionic in nature. Now if we consider the case of methane, the carbon's electronegativity is 2.55. Then what is the electronegativity of hydrogen? It is 2.20. Then the difference will be 0.35. So we can say the compound is covalent in nature. Now if we consider the case of magnesium chloride, the electronegativity of chlorine is 3.16 and the electronegativity of magnesium is 1.31. So the difference will be 1.85. We can say it is ionic in nature. If we consider the case of sodium oxide, the electronegativity of oxygen is 3.44. Then the electronegativity of sodium is 0.93. So the difference is 2.51. So we can say it is ionic in nature.
In a covalent bond, the ability of each atom to attract the bonded pair of electrons towards itself is called electronegativity. We can summarize the table by saying that if the electronegativity difference between the element is 1.7 or more than it, then the compound shows ionic nature. If the difference in electronegativity value is less than 1.7, then the compound shows covalent nature.
In a covalent bond, the relative ability of each atom to attract the bonded pair of electrons towards itself is called electronegativity. If the difference in the electronegativity value of element in a compound is 1.7 or more, the compound generally shows ionic character. If it is less than 1.7, the compound generally shows covalent character.
With the help of electronegativity scale proposed by Linus Pauling, now let's compare the electronegativity of diatomic molecules like fluorine, oxygen and nitrogen molecules.
Analyze the electronegativity value of diatomic molecules like fluorine, oxygen and nitrogen with the help of given electronegativity value. The oxygen's electronegativity value is 3.44, while that of fluorine is 3.98 and that of nitrogen is 3.04. What is the electronegativity difference in oxygen molecule? So the electronegativity value of oxygen is given as 3.44. We know that oxygen molecule contains two O bonded together. So the answer will be 3.44 minus 3.44, that is 0. What is the electronegativity difference in fluorine molecule? In fluorine molecule, we know that two fluorine atoms are bonded together. So 3.98 minus 3.98, the difference in electronegativity will be 0. What is the electronegativity difference in nitrogen molecule? We know that in nitrogen molecule, two nitrogen atoms are bonded together. So 3.04 minus 3.04, the answer is 0.
It is clear that the two atoms in homodiatomic molecules have the same electronegativity value. So we can say that they attract the shared pair of electrons equally.
The two atoms in homodiatomic molecule have the same electronegativity value. They attract the shared pair of electrons equally.
Now let's analyze the electronegativity of hydrogen chloride molecule.
Analyze the electronegativity of HCl molecule with the help of electronegativity scale. What is the electronegativity of hydrogen? Answer is 2.20. What is the electronegativity of chlorine? Answer is 3.16.
By comparing the electronegativity of hydrogen chloride, we can say that chlorine atom is more electronegative than that of hydrogen atom. So, chlorine has a tendency to pull the pair of electron towards itself. When chlorine is pulling the electron pair towards itself, chlorine attains a partial negative charge. The partial negative charge is represented by using delta. Since chlorine is pulling the electron pair towards itself, hydrogen will attain a partial positive charge. Such compounds having partial positive charge and negative charge within itself is called as polar compounds. Few examples of polar compounds are HF, HBr. The geometrical shape of the molecule is also a factor which determines the polar nature. For example, molecules like H2O, NH3 are also examples of polar compounds. Now let's watch a video of water explaining the polar nature.
That water molecule contains one oxygen atom covalently bonded with two hydrogen atoms. Since we know that oxygen is more electronegative than that of hydrogen, we can say that oxygen will attain a partial negative charge and hydrogen atoms will attain partial positive charge. We can say that water is polar just like magnets. Like Earth has two poles on it, water molecules also have polar charge, where oxygen has negative charge and hydrogen has positive charge. We can say that water molecules show cohesive property, that is, they have a tendency to bind together with hydrogen bonding. Say that water always have a tendency to stick together. Even in the case where water droplets are dropped out of tap, they have a tendency to stick together. Polar nature is important for few reasons. It allows a lot of things to dissolve in it. If we take the case where HCl, that is common salt, is dissolved in water, positive Na plus ion is separated from the negative Cl minus ion. This happens in water because of the way the positive and negative sides of water molecule can arrange around the ions. If something can have materials dissolve in it, it is called solvent. Due to solvent property, it is a great medium for the transport of iron and glucose in organism. Which atom in water is electronegative? Oxygen atom. Why is water considered as universal solvent? Water has the ability to dissolve many organic and inorganic compounds and therefore makes it universal solvent. Compounds having partial electric charge within the molecule are called polar compounds. HF, HBr and H2O are examples of polar compounds. The geometric shape of a molecule is also a factor that determines its polar nature. Water, ammonia are such compounds.
The difference in the nature of chemical bonding is reflected in the property of compounds. So now let's compare the properties of ionic compounds and covalent compounds. Let's take NaCl as an example of ionic compound and let's take wax as an example of covalent compound. And let's compare the properties of wax and NaCl.
Compare between wax and sodium chloride. We need to compare the properties like the state in which they exist, their solubility in water, electrical conductivity, melting and boiling point. Salt is taken as an example for ionic compounds. So now let's consider the properties of ionic compounds. They exist in solid state and they are generally soluble in water. They conduct electricity in aqueous and molten states. They show high melting and boiling point. Wax is considered as an example for covalent compounds. Now let's consider the properties of covalent compounds. They exist in solids, liquids and gaseous state. They are generally insoluble in water, but they are soluble in organic compounds like benzene. They are generally non-conductors of electricity and they show very low melting and boiling point.
So now we can say that the ionic compounds normally exist in solid state. They conduct electricity in their molten states and they are highly soluble in water. They have high melting and boiling point, whereas covalent compounds exist in solids, liquids and gaseous state. They are not soluble in water, but they are soluble in organic solvents like benzene. They do not conduct electricity and they show low melting and boiling points.
Ionic compounds are in their solid state. They are generally soluble in water. They conduct electricity in aqueous and molten states, and their melting and boiling points are high. Whereas covalent compounds can exist in solids, liquids, and gaseous state. They are insoluble in water, but they are soluble in organic compound. They are not good conductors of electricity. They show low boiling and melting point. Evaluate the nature of HF molecule with the help of Pauling's electronegativity scale. Since F atom has higher electronegativity, it pulls the pair of electron towards itself and attains a partial negative charge, and H atom attains partial positive charge. According to Pauling's electronegativity scale, the value is greater than that of 1.7. So we can say that HF molecule is ionic in nature.
Just like chemical bonding is formed between different elements, we should also maintain good relationship with all types of people irrespective of social status.
Follow-up activity. Calculate the difference in electronegativity of HBr. Calculate the difference in electronegativity of MgO. Represent the polar nature of HBr using delta symbol. Construct a ball and stick model of water molecule and observe its geometric shape.
I hope this topic is clear to you. Stay home, stay safe.
Thank you.